Okay, before I start my presentation, I just want to do a small disclaimer. All the proposals I want to show here are on stage 1 in the TC39 process, which means that the committee decided that the use case of this that this proposal tries to solve are valid, and it worth more investigation, nothing else. Okay, the main proposal here is to have a sneak peek about the future of the JavaScript and understand the use case, pros and cons of this, or each one of these features, and create some awareness about the amazing work that the C39 community is doing in order to make our language better. So if you have, one other thing, if you have any concerns or if you want to show your excitement about some of the features, or even though feature that I'm not mentioning here, go to this link. Is their GitHub repository. All the proposals they're working on is there. So the agenda for today is I will talk about pattern matching, pipeline operator, binary AST, and a dangerous thing. I will throw some opinions on that. So if you see this red border, it means it's my opinion. So if you disagree, let's talk to me afterwards, and otherwise just ignore it because it's just my opinion. With that, no sound. Come on. Okay. To give you a background motivation about the first proposal, I want to first talk about conditionals in JavaScript. In JavaScript nowadays, we have 3 ways to do conditionals. If-else statement, switch statement, and ternary expression. To help you to get the picture, an expression is something that evaluates down to a value, and a statement is just something that does something. I will show quickly how each one of these works. So an if-else statement requires a condition, which is surrounded by this parenthesis, and which can evaluate to truthy or falsy value. If the condition is true, it executes the first block, which is the curly brackets there. And if not, if it's false, it goes to the else block if there is one. Okay, just to help you to get the picture, I create this snippet, which is just a function that outputs emoji that mostly reflects the temperature. This is in Celsius. I forgot to translate this to Fahrenheit. Sorry. Okay. So as you can see here, like you have an if statement, and then if this is true, it returns like the fire. Otherwise, it falls to the else statement, which is another if statement. So with this, you can chain if and else statement, and this can go wild. Like I'm not even talking about like nested if. If you have like this kind of sequential checks with just a small code to react to this, I think switch statement could fit better. So let's check how a switch statement works. So as I told you, that if statement is very handy when you want to just react to a couple of choices, or we have a big chunk of code to run. But whenever we have like a multiple choice with just a small code to react to this, I think maybe switch statement could be a good choice. So how switch statement works? You have like between these parentheses an expression, and it evaluates this expression, try to match with one of these case statements. And once the expression matches to the expression inside the case statement, this is the entry point of the switch statement. So once the execution enters this point, it gets going until the end So that's why we have this break statement to jump out of the switch statement. So going back to our initial example, this is the way I just make rewrote the previous example using switch statement. As you can see here, oftentimes we just use the constant in the case statement, but here, since I want to access the truth value, so I put the constant in the switch expression and the comparison inside the case expression. The third one is the ternary expression. So the ternary operator became popular recently, most by the functional programmers, who tries to write the code with as much expression as possible. It basically works as the following. Give a condition. If it's true, it executes that block after the question mark. It's false. If it's false, after the colon. So since ternary is an expression, you can use error function to make that previous example more concise. But it is readable. I don't know. I'm not here to judge. There are people that really like this approach. As you can see, there are a lot of ways to do conditional in JavaScript today. What's the matter of the fourth one? Could you imagine what could happen if you mix if statement with switch statement plus the power of the structuring parameter? Pattern matching. So to understand it better, I create this toy example, which we have like a list of shapes with size, color, type, and I want to log all these circles, red squares, and big bow triangles. Just to contextualize, this will be our sample entry, and this is one potential solution for the problem. But it's tricky that it becomes tricky because it can easily become hard to reason about, because the more checks we have, the bigger is the if statement. And this is the way we can achieve this with pattern matching. So because of the time, I want to explain the core concepts of the pattern matching. If you are interested in this, we can talk more about this later. So this is the first part of it, which is the case statement. It defines the start of the pattern matching statement. So it receives just one value as input, which is inside this parenthesis, which is the case expression. So then we have afterwards the when clause. So the when clause is divided in two parts. The match pattern, which is this first pair of curly brackets, and the when clause body. So whenever the shape of the pattern, the pattern matches the shape of the expression, it gets into this. It executes this body. So as you can see, to achieve the second condition, I just need to create another query. Let's say another pattern, and so. In here, we have something different. You can check that we are matching the size, and then afterwards we have this if statement, which not an if statement. It's just it's called match guard. So whenever the first part matches, even though if the match guard returns false, we don't execute that body. We just skip. The last part is. Whenever we put a variable standalone on this match pattern, it just matches everything. So it's kind of the default statement for switch case. Okay. Even though pattern match is powerful, we should not forget to use the right to the right job. Remember our weather example. Using pattern matching, we could do like this. So keep in mind that not everything's a need to use a hammer. Okay, dangerous part. This brings me some wishes. Like since we have 3 ways to do conditionals in JavaScript, and 2 are already a statement. So I would like to see pattern matching land in JavaScript as an expression. So we could have, because now, as it's proposed as a statement. And I think having this, I know there are a lot of corner cases that needs to be covered to make this as expression, but I would like to wait more to have this and have this as expression. But if this lands as a statement, and if we have do expression landed in JavaScript, we can wrap pattern match with do expression. So let's go to the next one. Before introducing the next proposal, let's check what is function composition and how we can do this in JavaScript. So function composition is a mathematical concept that allows you to combine two or more functions to create a new function. Okay, so to help you to get the picture, let's cook a bento. I came up with this example just because I think it's easier to reason about food, and because I like to use emoji. Whenever you have a function that the output of the previous function you use as input to the next function, you think that you need to compose those. But to do this nowadays, one of the possible ways is to do this with these intermediary variables, but it becomes variables just because you need to create this variable just to hold this function, this value until you use this as input to the next function. So I don't want to use these intermediate variables. Okay, how can we do this better, right? I can do like this, but it's a trick to reason about because the way the data flow is different than the way we read the code, because the data flows from the inner function to the outer function, but the way we read is like top down, left to right. And there is one extra problem that the more we change these functions, the more nested we have this call, so it's not so readable. Okay, we can use Lodash flow for piping this function in a more readable way, let's say, or Lambda pipe, or even Vanilla.js, right? So wouldn't it be nice to have this capability somehow incorporated into JavaScript without having to rely to external library or some homemade functions? So let's bring the second proposal of this talk. Pipeline operator. So pipeline operator is a syntax sugar for this use case. It creates a streamlined chain of functions in a readable and functional manner, and it's backwards compatible. So that initial example of create bento could be used. Do I only have 5 minutes? Or really? I just started. Oh, I need to hurry up. Okay. Use pipeline operator, I can do like this. So it becomes clear that the way the data flows is the way I read the code. And this will be the sugar to this one. It's nice, right? So what if my chain function receives one more parameter? Let's suppose that we have this add fish to create a nigiri, and we need to define which kind of fish we need to add to the rice once we have it. So we could wrap this function with an arrow function. So, but in the minimal proposal, you need to wrap the arrow function with parentheses, otherwise you will have a syntax error. And okay, I just figured out that I don't know how to assemble a bento. So I need to delegate this task to an async third-party function. How to treat this async function using pipeline operator. So I could await this function, but the problem is this line 4 is ambiguous because I don't know, for example, if my implementation of the add to bento is just a straightforward async implementation, I want to have this function to be the sugar to this line 6. But if for some reason I have an uncommon implementation, which I return another function that I want to call with the rice to create the nigiri, or to create the bento, I want this line to be I want this function to be the sugar to the line 6. The problem is that the minimal proposal, there is no guarantee that I can, that await step could be the sugar to the one on another. Yes, as you can see, the minimum proposal has two caveats that needs to be addressed in order to have, in order to proceed in the C39 proposal. There are two competing proposals that try to address these two issues in different ways. I will first explain the smart pipeline proposal. So the smart pipeline proposal creates a token. So this token is like the placeholder for the results of the previous step. So whenever you want to, you have like to await a function, or you have to pass one extra parameter, like as I showed you, you can use the topic style, or whenever you have like this straightforward call, you just use the bear style. So just a couple of rules for smart pipeline. Whenever you have parentheses or curly square brackets, you need to use topic style. Otherwise, you can use bear style. Which brings to a small corner case, which is how to handle currying. So when you have currying, you have to use, thank you so much. I have 15 more minutes. Okay. Okay. Backtrack. Okay. When you have currying, since you have the parentheses, if you try to use the bear style, you have a syntax error. So that's why you need to create an extra call with the token. Okay, this proposal has extensive documentation for further enhancements after this baseline proposal. You should check that out. There are some links on the end of this presentation. So, as a counterpart, we have the F# proposal, which only tries to address the ambiguity of await step, of await by using an await step. So, it seems to be simpler than Smart Pipeline's proposal, but still we have to override the arrow function with parentheses, because the F# pipeline proposal doesn't try to address this one. Maybe because we still, maybe if we have the partial application landed in JavaScript, the partial application can replace this line with, of the arrow function. So, just to summarize everything about pipeline operator. So, it's a nice addition for creating a function composition in a streamlining way. The minimal proposal has two caveats. The smart pipeline tries to solve this by adding a token, and the F# adds just the await step. Okay, my point is, I really, really, really like pipeline operator, and I really want to have this shipped as soon as possible. So I would advocate for have I think that the F# proposal is just great. Like it's like just try to solve like a small problem, and then we could possibly having this shipped to JavaScript, and then afterwards the community could decide whether introduce a token as one way of solving these issues, of these caveats, as the smart pipeline tries to address, or I don't know, keep it as it is. Nevertheless, Babel 7.3 has shipped this smart pipeline proposal, so I invite you to try that out. Not in production so far, because this is not the syntax is not final. But please try that out. Okay. Before going to the last proposal of this presentation, I want to mention some performance tips. Have you ever heard about any of these JavaScript performance tips? Do you ever wonder why this is important for the performance of your application? To understand this practice and how they are important, the next proposal and how the next proposal tries to help to mitigate that, we need to check first how the JS engine is generally works. So, to hopefully explain how the JS engines work, I will show this illustration that I borrowed from an excellent article from Adam's Money. about startup performance in JavaScript. So whenever the browser finds a script tag, they download the text content of it, and then after it parses the JavaScript. And then generally the result of this JavaScript is something called abstract syntax tree, or AST, which is a tree representation of your code. So then afterwards, the browser uses this to generate the bytecode to do the first version of the running JavaScript. So this last part is more regarding the runtime optimizations that happens in JavaScript and makes the JavaScript execute faster. But this is not target of our presentation. Just to summarize, to put in short, JavaScript lifecycle could be described as generally as startup phase or loading phase. That's the download, parse, and compilation. Runtime phase, which is the proper execution, optimization, the optimization bailing out, and the teardown phase, which is the garbage collection. But here I want to focus more on the parsing phase. Why? Think about the code startup phase in JavaScript. We can see that it's crucial for the perceived performance of an application. So to make an application start faster, we end up doing those kinds of things that we just spoke on the beginning of this section. But one thing doesn't change, the parsing time. Parsing in the initial compilation of JavaScript could take up to 30% of the main thread time. And 1 megabyte of uncompressed JavaScript can easily take a whole second to be parsed in an average mobile phone. Normally, the browser needs to parse the whole file before compiling. And these are the motivation for the last proposal of this talk. Binary AST. So the binary AST proposal proposes a new over-the-wire format for JavaScript, which is based on the binary representation of a simplified custom AST. So this could potentially decrease the start of large JS application. And the browser that doesn't support it just can load the normal JavaScript file. So this is how this may work. First, we need to write our beautiful and delightful piece of JavaScript. So then you can compile it using your favorite flavor of a bundler transpiler, which provides such feature. And then the process will give not only the min.js file, but a bin.js file. And this bin.js file, it's a pre-parsed AST representation of your JavaScript file. So the browser that supports it can have the parsing phase drastically decrease in time, since the majority of this task is doing in the build time, right? So the champions of this proposal create a POC over SpiderMonkey and use a grammar based on its internal AST and try to compile some JavaScript in binary AST and measure the performance. And using the Facebook static newsfeed as a benchmark, the POC had the following outcomes. The result of this POC was the following. The size of the binary AST was slightly smaller than the JavaScript file. And the parsing of creating that JavaScript was between 500 and 800 milliseconds. But the time for creating the AST was twice as fast as before. So this POC showed some evidence that cheap plain binary AST was a good performance win. Create some second level of extra annotations on the binary AST file has enabled some dead code elimination without relying in the bundle plugins like tree shaking. And it can improve to the point that this annotation can improve to the point that we can enable streaming compilation. If the performance of this hypothetical streaming compilation was closer to the current WebAssembly streaming compilation, we can reach to the point that the compilation time for the enhancement AST, binary AST, could be faster than the load time. Amazing, right? So, to finalize, these are links for further reading. And these are my contact if you want to get in touch. And mahalo.